What is the fastest thing in the universe? The speed of light, which is 3 lakh km per second. Olaus Reumer was the first person to calculate the speed of light exactly. But before that, it was believed that the speed of light is infinite. If the speed of light were truly infinite, then our sky would be full of glowing lights. Light from the distant object continuously reaching us. There would be no night. The speed of light is also considered the universal speed limit, means that any particle having mass cannot exceed the speed of light, and the energy required to accelerate it to that speed would be infinite. Some physicists of Italy claim that neutrinos, one of the fundamental particles, can travel faster than the light, but their claim was proved wrong 1 year later. Speed of neutrinos is 29 crore 93 lakh 38,000 meter per second, which fell 4 lakh 50,000 meter per second slower than the light. Again, Einstein's prediction was right. Light travels so fast because light is made up of massless particles called photons, and all massless particles travel at the same speed, the speed of light. Some physicists argue that the phrase faster than the light itself is meaningless, because if you are imagining the speed faster than this, then it's not realistic. With current technology, we might not be able to beat the speed of light in vacuum, but we can beat it in other mediums. Light speed in water is 2,25,000 km per second, and light speed in glass is 2 lakh km per second, which is slower than the speed of light in vacuum. The universe is connected by lights, but even light is too slow at the universal scale. Light does travel at a very fast speed, but the universe itself is very large. And because of this, whenever you look at the night sky in a clear night, you look into the past. The closest star to us after the sun is 4 light years away. This means that the light released by the star that you are seeing now was released by the star 4 years ago. So, if you would look at the earth from that star, you would see yourself doing the thing that you had already done 4 years back in the past. But the real story isn't that simple. We can only see 46 billion light years away in every direction, not the whole universe. Some regions of the universe are too far away for the light emitted since the Big Bang to have had enough time to reach us. And this is called the observable universe. The observable universe is getting bigger in 2 ways. One is that space itself is expanding, and the other is that new light is reaching us. So, in future, more light will reach us, and more region of the universe will be visible. Suppose an object whose light is 13 billion years old must be some 40 to 45 billion light years away right now. That's because of the space is expanding. The universe is expanding at an accelerating rate, and a time will come when it will expand faster than the light. And since nothing can travel faster than the light, we won't see any event that is happening right now at more than 16 billion light years away. There are several ways to find out the distance between distant objects in the cosmos and us. For finding out the distance between us and the other objects in the solar system, we use radar. Parallax is used for finding the distance to neighbor star. For finding the distance to distant star and our neighbor galaxies, we use CIFITs. Edwin Hubble was able to find out the distance to Andromeda galaxy using CIFITs and proved that Andromeda is not a nebula or any gas cloud as a pupil of that time thought, but a whole different galaxy. And for the galaxies, even farther away, the amount of redshift of the galaxy tells us the distance to it. There is a galaxy called HD1 galaxy, and it is the farthest galaxy ever discovered. So when the light emitted by the galaxy was traveling, space itself was expanding, and it expanded the light too. And that increased the wavelength of the light, making the light reddish.